Kobe from eBay. I'm pleased to get the chance for sharing what we have done in eBay marketing, and thanks for joining this talk. Here, Beyond Lambda reflects the Beam strengths for unifying syntax and definition for batch-end streaming, and in reality, we can't avoid Lambda architecture sometimes, which are introduced by different infrastructure, platform, and optimizations. Then how we could figure out a way to use Beam for being close to the final approach. Then we could say Beyond Lambda. The agenda is simple. I will give introduction, why we choose Apache Beam, what's the challenges, and how we resolve them, what use cases, and our next step. Then I will try to answer all your questions. Recent several years, eBay offered lots of efforts for AI platform and build the AI ecosystem for driving business. You would see the enrichments for different domains. Check the link below how eBay transformed to a modern AI platform. Here, I'm working on big data for more than 10 years, like cross-system and behavior data with MapReduce, Pig, and Cascading, the Lambda-based streaming applications with Storm, also analytics platform with Spark. So higher abstraction for different process pattern and higher degree control for the process transparency are needed. That's why we go Apache Beam for marketing feature platform. So why Apache Beam? I think we already talk several points in this summit, which I will talk about two points mainly here. The pipeline portable helps potential change at the infrastructure and platform side. In reality, the company has different infrastructure, platform, and migration plan. How we reduce the effort for the integration and migration. The unified model helps you to decouple the business logic with specific transformation from different runners, especially in the age of public cloud. The language portability helps the integration with external components whose clients are written in different languages. Also sometimes improve the performance like a Kafka consumer. Then what challenges for using Apache Beam? First, streaming development requires you have concept for the extensions like window, watermark, and triggers, but one point must be specified in the coder with output schema for serialization and deserialization. The second one is the complex structure support, like nested structure and blob from data source or during processes, either introduced by different data publisher or security concern. Different data models are existing in any big company caused by different data sources and data pipeline. That's major reason why Lambda architecture fits for most of the user scenarios. Also, the checkpoint is needed, and we can't avoid how to tune the tuning for the large state. When integrates with the internal components, we need to handle authentication, eBay customized version, and also the metadata for different places. There are still some gaps from streaming feature to runtime feature for model serving. Even we could have feature selection layer or provide a container for pre-process before calling the model. But how to decide which part could be calculated in streaming time instead of serving time? Then we could reduce the serving latency as more as possible. About eBay currently platform and infrastructure, we could say eBay in the transmit stage, and the application have to ask capacity from different platform as the resource is not co-located. Also, we need to write different codes for serving online and offline use cases. Even pipelines are similar, and more pay points are introduced by different data models in online and offline behind the ETL and the different data sources. Then how we resolve it and how we iterate our architecture to achieve this goal. So let's focus on the left side first. That's our own situation. We have DB replay log and also have the for transaction data and also the tracking of production service for user behavior and application log. Both of them flash into Kafka topics. And we have Apache Beam pipeline built by our feature SDK for publish feature to Hadoop and Couchbase both. then serving online and offline and model execution. Also, we have green lines here, which contain large amount of ETL process by Spark, have MapReduce, and others for serving analytics and scientists before, and they may or may not use the same data source as Apache Beam. So if we want to have the same codes for historical feature generation in the plan for all those batch jobs should use Apache Beam as well. And we know it's ideal situation like the right side. As you see, the feature kits contains SDK, publisher, and serving, and I will talk about SDK mainly later. So here, feature publisher have schema inferring, auto registration, and query capability to aggregate and publish on offline features to online if needed. And we have metadata and feature selection policy for feature serving at the right time. Then back to the right side, we could see FAST is trying to hold in that entire life cycle from feature registration, feature generation, and serving in the notebook, and all features are generated by the same pipeline from Apache Beam. This is the ideal way for beyond Lambda, and the left side of our situation is likely in the transmit stage for powering Lambda and upgrade to beyond Lambda iteratively. Then, about the coder, we specify different coders for different transformation. Although we have a schema coder, row coder, auto-value annotation, etc. for helping us, but nowadays, data objects are usually self-described and schema-free, like Avron, Protobuf, Parquet. The question is, could built-in transformation not require coder explicitly? When I first see we need to use the apply method on the data objects, it's not very user-friendly and straightforward, as we need to search and pick corresponding transformation for the data and then set the coder. If you check Spark from RDD to data frame or Flink dataset, they are either leveraging internal type implicitly or have the infrared type information to use those operator on the data set directly to avoid the coder setting and to avoid the apply method always. So since our data source are almost coming from Kafka with the Avron format in eBay, we could come up with the coder auto-generation for Avron, but we can't benefit from Beam's own type inferring based on Beam schema. Also, we notice the Beam schema definition is more generic. So we convert Avron schema to Beam schema, generic record to Beam rows implicitly in our earlier stage. I know right now Beam have so many utilities surrounding it as well. Also, we have option for learnable and case insensitive for this conversion. Then, what built-in we add for schema-based transformation? First, we could provide more method for user to get output schema from existing one. Since the schema is associating with the field, you could apply those methods on nested field as well. The same method ended in Beam rows too, and both of them serve corresponding transformation. Finally, we could have different simple methods for peak collection to help user for converting complex row to another structure without setting the coder explicitly. Then how it looks like. And first, we could get the peak collection for responding the Kafka topic, which is described by the dataset directly. Then we have several own operator like select, where, to Avron, to Hadoop, distinct count, and enrich cast, group by, window, etc. Since it's peak collection from Beam itself, surely you could call apply method for your own transformation or apply cycle. Also, you could custom watermark for your input stream. And then we have actually, we should not always group by something and to put all the elements in the memory. That's the earlier version. Then we have implementation for some operator like a distinct count with stateful annotation, which you already see the hyperlog log in last session. And there is no reason to put all the elements in the window. Right? You could see we use the Beam state for dedupe and the combiner count for distinct count later. Then also we have our own implementation for distinct count with a stateful annotation. Also write a corresponding test for the custom operator with the utilities from Beam itself. Here is testing our implemented distinct count. And also apply your own transformation or use SQL or use our provider operator in the same way. In that way, this looks more straightforward for our customers. Yeah. And also at the beginning, we have some print method in the pipeline to check the schema change. Since we know the coder, we know the input schema, output schema. Of course, we will know the schema change for our entire pipeline. But we will have interactive way to develop a streaming job in notebook in future. We don't need to do that. That developer could check a collection schema by themselves, step by step, in the notebook in future. Then how we consider nested structure support? We have selector like we could have selector like XPath or CSS for path accessor and generator for bin schema, like user.userid or user ID with index or just user ID for all of them. We could have feed selector and lambda for the new field value to associate with the field builder. Then we consider the same way for predict, append, and other operators for nested structure support. And Beam did similar stuff in later version. That's why Beam put those transformation in schema package. We also meet a side effect like a type projection when we do schema-based transformation. We need to reconstruct the schema and row accordingly, like select a single element from array of row. It could be changed to array of long, but when come to two or more elements from same array of row, it's keeping the same type, which means the same parent will be reserved for keeping selected children in the group. This is the difference with Beam select and CSS selector, but we have our reason to keep that children as a group together. And also, after going through the main part for our feature SDK, how we integrate with internal components in eBay. eBay has an internal streaming platform based on Kafka and Flink. And in earlier version, we meet several issues for the integration. And our streaming infrastructure provides very good dashboard for us to check the cluster usage. Actually, this is the old version. We also have a more fancy one. Yeah. Also, the application status too, by leveraging Beam's metrics like the watermark, like the input, and also the job obtained and the checkpoint number, field checkpoint number, and also the job for restart time. And for Kafka and Couchbase, it's easy for us to integrate with Kafka with schema or wireless deserializer. Then you would notice we have a feature and a feature set under the same key with a 10 slot, but different formats. JSON is for streaming feed to leverage the subdoc as an index for upstart. And then binary is the feature set for batch. So feature selection could determine which one is enough or should combine both of them for our model serving with the batch and the streaming features. Why Couchbase? Because the eBay infrastructure officially supports Couchbase Wheel for online service. So we use it as a feature store for our model serving with low latency. We want to try Redis as it supports different data structure in memory. Also, we want to try HBase or TiKV for 10 servers features. Even we want to have a store category feature in search store for different classifications. And to be honest, I think we should not limit by the infrastructure for choose any data store for serving our model with the features. Then we tried different solution for Hadoop authentication. I will not go deep dive for this part. And And we provide a different file naming and partition function based on the record value. So normally our data will be partitioned by eventing window. In such way, downstream could query the data based on the time bucket in Hadoop, or schedule new job based on maximum 10 slot of last job. We tried hcatalog, but it does not support dynamic partition, and we want to have data lake I/O, but we don't want to handle transaction log by ourselves. We can't avoid small files if user want to publish the data with very low latency in Hadoop. So we provide generic tools for file compaction and partition alter to include the latest update in the table. Then the visualization of watermark could help you understand the data delay situation for every stage in your pipeline and end-to-end latency exactly. Then how about large state tuning? Originally, we have our own Flink for POC and use RuxDB and Hadoop as state backend. You could see how incremental checkpoint saving in HDFS. Then we switch to eBay streaming platform, which uses RuxDB and Safe as state backend. We have many nudge jobs. Back pressure actually is not enough sometimes when job is catching up. Since Flink does not consider checkpoint metrics as one indicator for the back pressure sampling, especially in the earlier version of Flink has not integrated with Kubernetes resource management for calling the API server. So the port loss is very frequent. The port loss, then checkpointing fail, then next checkpoint will get worse. So either we reduce the total size of job state or reduce the state for each task or improve the throughput for the checkpointing. I will not deep dive for all the tuning methodologies here, but we have many, because the time is limited, I will go finish the slides first. And then come to the batch feature. At the beginning, we want to have a Flink runner for streaming feature and the Spark runner for batch feature. Then we could unify all pipeline with our Apache Beam. Then we noticed the Beam capability matrix of Spark is not covering all we want at that time. But right now, we already started. Yeah, and also we want to adaptively compatible easily with existing user Spark code, like them leverage our pipeline. So actually, when we start to do the abstraction, we are more and more close to the Beam's own abstraction. We are not aiming to do that, but seems like the pipeline pattern and the data-oriented thinking is similar. Yeah. Then how it looks like, and we have several hundreds of feature sets already being published with Airflow scheduling in eBay marketing, and we also have a reachable feature catalog for scientists to search and check. Since our team also take care of model serving in eBay, we have planned to help scientists to pick the correct and proper feature for the validation of the model during the model development. And we have many interesting use cases like inventory, hotness signals, and co-view signals, user reaction, etc. And we believe we will have more and more use cases and reachable ecosystem upon Apache Beam. And we are ongoing the Python SDK and the notebook, because we still see some gaps for portable and interactive runner, and we are trying to integrate with eBay's internal components with security check and third-party dependency and others. Yeah, and also we already latest Beam and Flink. Just wait Flink 1.11 support. And we have a plan for data lake integration, and we already start our new feature store investigation based on eBay infrastructure. So thank you all for joining this talk. Most parts are higher level introduction about what we are doing in recently 1.5 years with Apache Beam capability, and I hope it give you some insights of what we are doing.
Thank you very much, Kobe, for this introduction of Beam at eBay. And unfortunately, I think we are already out of time. So
Oh, sorry.
I suggest, no worries, but I suggest we do the questions in Slack. Yeah, and I think you'll stick around, right? So
Okay.
cool.
Okay. Okay.
All
Thank
right.
you.
Thank you very much. Bye
Thank you.
bye.
Bye.